good afternoon, everybody. Today is lecture of December 2nd, 2024, Supplier Management. And today we will look at an important aspect that relates to network science. Those of you that have been already with me in previous semesters know the topic a little bit. Network science is a very relevant topic for the future. It's also transversal knowledge, so if you're interested, you can read the book Network Science of Barabasi. This is the world leading expert in network science. He's from Hungary. He wrote a book in 2016, although he teaches in the US. Okay, so this book is really good. So our lecture is not based on the book, but I think you would benefit if you would take it and read it. Okay, so today we look at again, strategic applications of network science. I'm not going to write NS because we're in Germany and that has a bad meaning. In supplier management. Okay, so this is our topic today. Strategic applications of network science, always with the background supplier management, of course. So why a strategic approach to network science in supplier management matters? Basically, supplier management operates in an increasingly complex and dynamic environment where global but also local networks dominate. A strategic approach powered by network science enables companies to understand, describe, and optimize or design and optimize their supply chains as interconnected systems. Okay. This goes beyond operational efficiency to encompass strategic insights, resilience, and innovation. Okay, so we will explore several topics today, specifically 5 main topics. And yeah, let's go one by one. The first one is the strategic value of network science in supply or supplier management. Okay. So this is our first topic today, and the key here is we move from, well, you all know what is a network, right? So that's intuitively a network, and so far we have been taking basically into consideration the relationship between one supplier and one customer. Now we go and we expand this concept to many suppliers at the same time. Okay, so we have not only what we called or what we would call tier 1, the first level suppliers. Okay, so this would be, let's say, tier 1 suppliers. First level. But we go and increase the scope to also to the tier 2 suppliers and tier 3 and so on. Okay, so if let's say this is our main node here, those nodes that are away one step are tier 1, and those that are 2 steps away are tier 2, and so on. Okay, so now we take a network approach to the business, and this makes things more interesting, more complicated as well, more complex. So we move beyond individual suppliers. Okay, so traditional supplier management emphasizes dyadic or dyadic one-to-one relationships, focusing on improving specific supplier performance okay, network science shifts the lens to different perspectives. So you have multi-tier visibility. Okay, so here we understand the dependencies. And flow of goods. Across multiple layers. Okay. The second is to look at interdependencies. So we capture how disruptions at one node affect the rest of the network. And the third one is system-wide optimization. Okay, so balancing cost, resilience, and performance across the entire network. Okay, across the whole supply chain. So the first thing we do is make sure we understand we're moving beyond the individual supply towards a network perspective. Okay. Second thing that's important is that we are addressing supply chain complexity. Okay. And so using network science strategically helps us with different aspects. So reduces blind spots, so identifying hidden risk, in multi-tier supply chains, enables proactive decision making, using predictive models to anticipate disruptions And 3, fosters innovation. Because it highlights collaborative clusters for co-development and cost sharing. So once we are aware that we're not only looking at one-to-one relationships, we're looking at the whole network. Now we're addressing the whole complexity. The third aspect here is that we are able to align network science with business objectives. Okay. Those key strategic objectives, some of these key strategic goals might be, first one is cost leadership. Okay, reducing inefficiencies through better network design. Differentiation. Enhancing customer value. By ensuring faster delivery, or better quality, through strategic supplier positioning, and the third one is build resilience into the system, into the supply chain. So building adaptive supply chains that can withstand disruptions. Disruptions can be geopolitical or can be weather-wise or something like that, okay? So, any questions so far? Thumbs up, thumbs down, something? All right. So here are some, not all of course, but some of the key concepts that if you read the book of Barabasi, I mean, you told me you didn't want to look at math, which I understand. So normally I would go into the math of this and I would give you the formulae to describe these concepts and to calculate them yourselves and stuff. You said you're not interested on this explicitly, so I respect that. If you want to do business with these concepts, you will need to be able to measure all these things. Okay, so you need to be able to investigate in the book I gave you above if you're interested. Okay, so I'll just give you the key aspects, and then key network. If you're interested, you can contact me, of course, and we can go into the detail, okay? Or supplier management design. We can go into the detail here, but this requires math, okay? So the first thing, the first concept is the graph analysis. Basically, you can describe a network as a graph. A graph is mathematical. A graph is a mathematical concept which describes networks. Okay, a graph G is a list of nodes which could be suppliers, manufacturers, distribution centers, customers, but anything that deals with material or information flow. So you have the nodes, you have the edges connecting those nodes, which could be flow of goods, flow of capital, flow of information, flow of energy, flow of whatever the fuck you want, okay? And the weights, which could represent strategic factors like volume, cost, or criticality. Criticality with one L. Okay. So this is a graph. It's something like a list. As I said, is you have the nodes, the edges, and the weights. You can describe a graph like graphically as well, okay? The information flow going and material flow coming and whatever, okay? So there are many ways to, you can use different colors for different types of nodes, and I mean, this is everything very much customizable. There's a whole theory behind the representation and the measuring of this. Okay, so key strategic questions to ask include, they're not close to, but they include which nodes and edges are critical for resilience. How centralized is the network? The resilience question is important. Why? Because let's say if this node fails, the network becomes two networks. Okay, so things start getting nasty, and you don't have the supply chain. But whereas if this node fails, the rest of the network can maybe still survive. Okay, so the nodes are not equal. So to identify which nodes and edges are critical for, so imagine this is a connection between two factories. If this edge fails, the network just fails to connect. So you have two networks, and there you have a problem. Okay, so not all nodes and edges are the same. Second question is how centralized is the network? Or other question is, are there unnecessary bottlenecks? Or where can redundancy add the most value? You can ask many strategic questions that are related to this topic. So the second thing is you have certain concepts that you can measure. Okay, you can have key strategic KPIs to measure supplier management from a network science perspective. The first concept that's maybe important is centrality. So it measures or provides insights, provides insights into the strategic role of different nodes in the supply chain. You have something called betweenness centrality. This can be calculated. Okay, so identifies critical suppliers acting as intermediaries okay, losing such a node can fragment the supply chain, okay, just as we saw earlier before, or eigenvector centrality, so identifies influential suppliers connected to other critical players it highlights systemic risk, highlights systemic risks, or closeness centrality, identifies nodes that can efficiently distribute products, ideal for logistics, optimization, okay. Once you look at centrality, you can go and look at centrality of nodes. You can go look at modularity and clustering. Modularity and clustering. Which clusters represent groups of closely connected suppliers or regions. So you can have high modularity, useful for isolating risks in localized disruptions, So whenever you have a very highly risk or high risk supply chain, you want to have a high modularity so that units can operate independently from each other, or you can have low modularity in place, promoting flow efficiency. But increases global interdependencies. Yeah, okay. So these are some, not all, but some of the aspects that could be relevant when you apply your analysis to your network science analysis to supply management. Okay. Any questions? No. Okay. Then let's look at the third aspect, which is strategic applications. Of network science in supplier management. Okay. Some examples. Okay. First one is supply chain resilience through redundancy. Okay. So network science can help you identify where redundancy is most needed by evaluating vulnerabilities in the network. Okay. So, for instance, for example, you can make a critical single point of failure okay. Those are suppliers or facilities with high betweenness centrality is a KPI that we saw up there, centrality here, but no alternatives. Okay, so if you find in your analysis a node with a high between centrality, but you only have that node, that point is a critical single point of failure. If that supplier or facility fails, then you're in trouble, okay? Or you can go and say, okay, I have my cluster risk. Okay, so geographic clusters. Or suppliers vulnerable to share risk. Like natural disasters, or political instability. Okay. So the strategic action here is to first diversify, critical nodes, and create redundancies. And second, negotiate contracts with secondary suppliers for on-demand scalability. Okay, so this would be one aspect, the resilience of the supply chain. Questions on this? No? You cool? Great. So let's continue with 3.2, supplier collaboration. And innovation networks. Okay. So analyzing modularity can highlight clusters where suppliers can collaborate on innovation. Okay, for example, automotive suppliers working in closed networks can co-develop electric vehicle components. Okay, so here the strategic actions would be: 1, promote partnerships. Within high modularity clusters. And 2, encourage co-investment in technology platforms. For shared innovation. Okay, so for instance, you might know the company Audi. Okay, Audi is born as a co-investment company by Mercedes, BMW, and Volkswagen. Okay, that at some point Volkswagen takes over, but that's basically the thing. Okay, so maybe one third aspect, 3.3 would be predictive disruption management. Okay, using network analytics, companies can simulate disruptions. Okay, so you can work on, for instance, and you can go and describe your network and then say, okay, what would happen if I would take this node off? So you can say node removal analysis. Okay, so examines the impact of removing critical suppliers. Okay, what would happen in performance and stuff. Okay, or flow redistribution. Okay, oh, sorry. Flow redistribution, simulate how goods can be rerouted in real time. Okay. So what are the strategic actions here? Develop preemptive contingency plans for high-risk nodes. To invest in digital twins. For real-time simulation. This is something that you could develop for yourselves, not very expensive. You don't need a supercomputer to do that, and by developing these skills, you can secure a job, basically. Okay. So I repeat again, all this you can measure with programming, with Python, with math, basically. If anybody is interested, I can provide you with more material, okay? Or background material, maybe for your bachelor work, bachelor arbeit or something. So the fourth point, skipped one, it's not so interesting, I think. Challenges and future directions. So for one, challenges. The first and main is the data availability. No data, nothing can be done. So the lack of visibility of tier 2 and tier 3 suppliers is it's a big dumper when you want to do this sort of analysis. The second one is dynamic networks. So supply chains evolve rapidly, requiring frequent updates. Frequent, I mean daily updates. It's very challenging to perform such updates on a real-time basis if you don't have data. And then the coordination cost. As we saw last week, whenever you do something correctly with contracts and everything tends to be slow, but business tends to be fast. So to coordinate these two speeds might be a challenging task. Okay. So implementing changes across networks. Can be expensive. And time consuming. Okay, so future directions. would be, I mean, this is not a closed list, but AI-driven networks, machine learning models, can predict disruptions, and optimize flows. In real time. I mean, you have used Google Maps to avoid some traffic jam or that kind of stuff. Okay, so this is basically the technology is not the future. I mean, it's not even the future. It's just right now. Okay, happening right now. Blockchain integration. This enhanced transparency. And trust, because manipulation is avoided. And then also important sustainability metrics can be taken, so you can embed environmental and social impact as part of the equation through network science models. Okay, just as we were talking about information flows, you can also talk about environmental flow, sustainable flow and stuff. All right. So, any questions? Okay, no questions. I hope you enjoyed the lecture. This is important stuff. I mean, from the bottom of my heart, recommend you read this book by this Hungarian/American scientist, Barabasi. He's the best in the world right now. He's does this research, and his book Network Science is really, really good. Okay, so I hope you enjoyed, and if you have any questions, don't hesitate to contact anytime. Have a rest of a week that's safe and be healthy. Bye-bye.